Section 1.2.3, Compound Inequalities. A compound linear inequality contains more than one inequality sign, such as 2 is less than or equal to 5x minus 3 is less than or equal to 12. To solve, isolate the variable in the middle, applying the necessary operations to all three parts. The solution will look like 1 less than or equal to x less than or equal to 3, which is bracket 1 to 3 bracket in interval notation. So solving a compound inequality involves isolating the variable in the middle. When we solve a simple inequality, we isolate x on one side of the inequality and we apply the same operations to both sides. Here, our focus is the middle. Whatever it takes to isolate x in the middle, we're going to apply all those operations to all three parts. So we're just managing more information. Example 2, solve each inequality, write each solution in interval notation, and graph the solution. Example A, 10 is less than or equal to 2x plus 4, less than or equal to 16. So our goal is to isolate x here in the middle. So just focusing on the middle, to isolate x, the first thing that I would want to do is subtract 4. So I'm not only going to subtract 4 from the middle, but I'm going to subtract 4 from the other two parts as well. So we're applying that same operation to all three sections. We end up with 10 minus 4 equals 6, less than or equal to 2x, less than or equal to 12. Again, keeping our focus on the middle, we have x multiplied by 2 in the middle, so to isolate x, I'm going to divide all three parts by 2, and notice that's going to get x by itself in the middle. 6 divided by 2 is 3, less than or equal to x, less than or equal to 6. So any number between and including 3 and 6, if I plugged it into the original inequality, would make a true statement. Let's put this on a graph. So I'm going to put the endpoints of our interval here on our number line. Notice x is trapped in the middle of those numbers, so I'm going to shade in between those numbers. And because both of our inequality signs are inclusive inequalities, we're going to use a bracket on the ends. Once we have our graph complete, interval notation is very simple. The leftmost value is 3, the rightmost value is 6. So the solution to the inequality is any number between and including 3 and 6. Now, if I took 3 and I plugged it in for x in the original inequality, I would see we have 2 times 3, which is 6, plus 4. The value in the middle would be equal to 10. So plugging in 3 causes the middle to have the same value as the original left side. If I took 6 and I plugged it in for x here, 2 times 6 is 12 plus 4 gives me 16. So plugging the endpoints in shows that we have equalities on either side. If I choose a number between 3 and 6, such as 4, for example, 2 times 4 is 8, and 8 plus 4 is 12. 12 is between 10 and 16. So again, with the brackets, you're achieving the equality, and then everything in between gives you a true statement. Let's work on a compound inequality that contains a fraction. Now, as we've been doing, we're going to multiply all three parts of the inequality by that LCD. That's going to cancel that denominator. So I'm going to write in the center here 3 over 1. To make it compatible with that fraction. And just an ordinary 3 over here to join with that 1. So we have all of our original terms. We're multiplying all three parts by 3. We can see the 3's cancel in the middle, and we end up with negative 15 less than or equal to x minus 3 less than or equal to 3. Our goal now is to get x by itself in the middle, and we can do that by adding 3 to all three parts. Negative 15 plus 3 gives me negative 12. And 3 plus 3 gives us 6. So on our number line, we need to shade the numbers between and including negative 12 and 6. I think this is going to be a longer graph, so I'm going to count by 2s to see if I can fit everything on the graph. Perfect. Then we're going to shade all the values between negative 12 and positive 6. And each of those signs is an inclusive inequality, so we're going to use square brackets on the end. So the solution to our inequality in interval notation would be the leftmost value, negative 12, to the rightmost value, 6. So to solve a simple inequality, we isolate the variable by itself on the left. To solve a compound inequality, we isolate the variable by itself in the middle. And in either case, always remember to reverse the direction of your inequality if you multiply or divide by a negative. If you multiply or divide a compound inequality by a negative, you would reverse both inequality signs.